So today we're going to talk about graphing exponential functions. So the two examples I'm using for you here is y equals 2 to the power of x and y equals brackets 1 over 2, close the bracket, all to the x. In this example that I'm going to use, I'm just going to do table of values and I'm going to explore some numbers. So I'm going to go maybe with -2, -1, 0, 1, 2. So if I put in -2 for the x there, 2 to the power of -2 is the same as 1 over 2 squared. And 1 over 2 squared just gives you 1/4. If you put in -1, 2 to the power of 2 to the power of -1, to make the exponent positive, you just flip it. So it's 1 over 2 to the power of 1. Just if you want to see how that happens. And therefore it's 1/2. 2 to the power of 0, anything to the power of 0 is 1. Anything to the power of, 2 to the power of 1 is 2. 2 to the power of 2 is 4. So now I'm going to go ahead and start maybe plotting some of these. So -2 and 1/4, which is around here. -1.5 is around here. There, 0 and 1, it's around here. 1 gave me 2, so it's right there. And 2 squared gave me 4. And therefore, this graph just looks like this. So these are the points right here, and so on. So simply table of values, and then you'll know how this graph looks like. What you should know for an exponential graph, the domain, if you don't have any translations, transformations in the graph, the domain is x is all real numbers. The range, however, it's y greater than 0. And as you see, this graph never touches the x-axis. It gets very close to it, but it'll never touch it. And that's why it's y greater than 0. Now, how about if we want to graph y equals 1/2 to the x? The trick here is to change this to 2 to the power of -x. Because what you do, you flip this and you make the exponent negative. So therefore, if you want to graph this, 2 to the -x compared to y equals 2 to the x, it's a reflection in the y axis, or a reflection over the y axis. Yeah, and therefore, all you need to do, just take all the points, reflect them in the y axis. And any of you, if don't know what happened there, the chapter of transformations talks about this very clearly. So if you have a negative in front of the x, it means a reflection in the y-axis. If the negative is in front of the whole thing, then it's a reflection in the x-axis or over the x-axis. So I'm just going to use another color to graph the other graph, and I'm just going to use red. So basically, y equals 2 to the -x. It's a reflection of this graph in the y-axis. So you take this point here, it's 2 away from the axis of symmetry. So you go right there, because your axis of symmetry is the y-axis, and you go 2 to the other side and plot your other point. And this is 1 away, so you go 1 away. And this also 1 away from the y-axis, so you go 1 away, and then the quarter here is 2 away from the y-axis, so you just go 2 away and you have your other point right there. And therefore, if I want to graph this, it is basically looks like this. And that's how we graph exponential functions. Okay. So now let's explore another one that's maybe a little bit more complicated. And what I'm going to use transformations to graph it. So here's another graph that involves some transformations. So if you're looking at this right here, you want to compare this to y equals 3 to the x. So let's look at the graph y equals 3 to the x. What kind of points are we going to get? So when x is 0, 3 to the power 0 is 1. So I'm going to get a point right here. When x is 1, 3 to the 1 is 3. So when x is 1, y is 3. And when x is 2, 3 squared is 9. When x is 2, y is 9. And then with the exponential graph, we know it gets very close to the x-axis. So it gets very close to the x-axis as it goes to negative infinity, and then it shoots up as the x goes to positive infinity. So this here is the y equals 3 to the x. Now, if you look at this graph here, you know, the transformations you have here, the x plus 1 means the graph moved left 1, and minus 2 means the graph went down 2. That's from the chapter of transformations. Now, I'm going to graph this now in a red color. And the first thing, as we know, we have a horizontal asymptote for exponential graphs. And since this graph has gone 2 down, so therefore your x-axis will be right there. And now let's look at these 3 points right here and look where they're going to move to. So this moves 1 to the left and 2 down. So that point will go right there. This is 0 and 1. Also the 1 and 3, it will move left 1 and it goes down 1, 2. So it just overlaps with this point right here. And this point here, it will go left 1 and down 1, 2. And having these points now, I could just graph this transformation right there. So this is the transformed graph of y equals t to the x, and that's what it became. Now, if you decide to do table of values, and you start with x and y for this one right here. So let's say if you go x is -1, I'm just gonna use the points that I did here to see how we got them. So when x is -1, that became 0. 3 to the power 0 is 1. 1 minus 2 gives you -1 right there. How about if we sub in 0 for x? 0 plus 1 is 1. This becomes 3 to the 1, which is 3 minus 2 is 1. So we have 0 and 1. And if you sub in 1 there, 3, that becomes 2. 3 to the 2, or 3 squared is 9. 9 minus 2 is 7. And therefore, that's why we got -1 and -1 here, and the 0 and 1 right there, and the -1, oh, sorry, the 1 and 7 right there. If you decide to use table of values, just be careful. Make sure you know your asymptote went down 2. And if you plug in numbers and you're getting numbers that are very big or really small, you know you have to change your points till you get points that make sense, and you could draw them on the grid right here. Yeah. This is it for graphing. I think there is one thing that I'm gonna go over. It's this graph right here. So here they've given you the graph and they want you to find C. Yeah, as we know, X and Y variables, they change as you go along. But what's the value of C? What power is this? Or what's the base basically that gave you this graph? So now if we go Y equals C to the X, and just sub in any of these points here. So here, let's say start off with maybe Y is 5. So the point 1 and 5 here equals C to the 1. Now, obviously that C here is 5 because 5 to the power of 1 equals 5, and therefore C equals 5. And even if you try the 2 and the 25, 25 equals C to the power of 2 because that's X and Y. And then you realize that C has to be 5 because 5 squared is 25. So the same as here. So this is how you solve these kind of questions if they give you the graph. Till next time, stay safe. Math is like a puzzle, and puzzles are fun to solve. Take care. Happy New Year again. Till next time. Adios.